For joining us tonight. Tonight's Fertility New Zealand webinar is on the current ACART consultation on research involving human gametes and embryos. ACART is the Advisory Committee on Assisted Reproductive Technology, and we're excited to team up with them tonight. A big thank you to our webinar sponsor for the series, Merck. And we want to tell you a bit more about Fertility New Zealand before we get started. So Fertility New Zealand walks alongside all people facing fertility challenges. We do this through providing support, information and advocacy services. You can contact us through our helpline and our regional and topic support groups. And you can connect with us on social media. We're on Facebook, Instagram and LinkedIn. You can also join Fertility New Zealand as a member. Membership is free. And by joining, you access some additional resources and you support the valuable work that we do. Please visit our website for more information, resources, fact sheets, videos, webinar recordings, newsletters, and more. Our website is fertilitynz.org.nz. It's just some examples of our website on there for you. Tonight, ACART committee members Callum Barrett, Dr. Sarah Wakeman and Dr. Karen Reeder will talk to us about the current consultation, the guidelines, the review and the feedback process. Calum Barrett is the chair of ACART and works for the Tertiary Education Commission, having previously worked in policy roles with the Royal Australasian College of Surgeons and the New Zealand Police. Dr. Sarah Wakeman is an obstetrician and gynecologist, subspecialising in reproductive endocrinology and infertility. She's been working in the area of infertility for 16 years and is currently the Medical Director for Fertility Associates in Christchurch. Dr. Karen Reeder is a lecturer in the Department of Pathology at the University of Otago, undertaking research and teaching in reproduction, ovarian and prostate cancer. Without further ado, I will now hand over to Callum to start the presentation.
Well, kia ora, and big thank you to Fertility New Zealand for hosting us tonight. Being able to share the work that ACART is up to and hopefully answer some questions is actually a really important part of our work. So we're really grateful to everyone who's come along tonight. Tonight, we're talking about human reproductive research and I guess primarily where the regulatory regime in New Zealand might be headed. This is a really exciting work item for ACART. I think it's sort of the first time in 20 years that we've actually had the opportunity to have a look at the research regime and make changes. It has tremendous potential to actually help people and improve fertility treatment and also give some more options to people who might have their own gametes or embryos in storage. A few more options with regards to what to do with those once they finish their fertility treatment. So it is a really exciting piece of work, and we're really hopeful that it's going to make some really positive changes in New Zealand. It's a really big project as well. It's probably going to take us a couple of years. As Lydia mentioned before, we do have a consultation out at the moment. I'll probably refer to that several times throughout the night. Consultation is a really big part of what ACART does, and the submissions we receive can have a really tremendous impact, I guess, on the direction that we take. So we do really implore you that if you're interested in the material tonight and you would like to share your views, we'd really welcome those. So as I just said, my name is Calum Barrett. I'm the chair of ACART. I'm joined by Dr. Sarah Wakeman, who is our clinical expert, and Dr. Karen Reeder, who's our research expert. We've set out, I guess, the following framework for tonight to try and I guess, talk you through our thoughts. I'll be covering the first sort of bit of the presentation, which is providing some background context. So ACART, who we are, what we do, what the current state of human reproductive research in New Zealand is, and how you can shape the future of human reproductive research. Sarah's going to then talk about what embryos are and where they come from. I appreciate that probably a lot of people listening today have lived experience of this already, so it might be treading familiar ground. However, I guess embryos and I guess the difference between non-viable and viable embryos is a really important part of human reproductive research. So we thought it'd be helpful to outline that. And then finally, Karen's going to have a talk about possible types of human reproductive research. I'll have a quick talk about next steps, and then we should have about 30 minutes for questions, and those can be related to human reproductive research, although we're very happy to answer any questions related to ACART generally if you have them. So ACART, who we are and what we do. I mentioned before I'm the chair of ACART. More importantly, I'm the consumer member, so I do have lived experience of assisted reproductive technology. These are my 3 kids, Tavish, my oldest on the left, Cecilia on the right, and the chunky fellow in the middle is Tan. Now, we didn't actually need any assistance with Tavish or Cecilia. However, Cecilia was born with cystic fibrosis, and so me and my partner discovered that we were both carrying cystic fibrosis genes. So in order to complete our family, we did have to use pre-implantation genetic diagnosis and IVF to actually ensure that Tan was born without cystic fibrosis. So he was born last year. He's a happy fellow. He's huge. And if he slept a bit more, that would be really lovely. So ACART is a statutory committee. We are established by the Human Assisted Reproductive Technology Act, or the HART Act for short. That's the primary piece of legislation in New Zealand which regulates assisted reproductive technology. Our members are appointed by Cabinet, usually following an application process, although occasionally people do get shoulder tapped if they have a specific skill set. And we have between 8 to 12 members. It has to be a multidisciplinary committee, so we have to represent lots of different views. As I said before, I'm myself, I'm the consumer member. Sarah is the member with clinical expertise. Karen has research expertise. We're also required to have a member who's got ethical expertise, another with legal expertise, a member with Tikanga and Māori expertise, and also someone who can articulate the interests of children, and that's usually someone from the Office of the Children's Commissioner. We also have lay members appointed to the committee to sort of bring other skills. And at the moment, we have members with governance experience, members who can represent disability perspectives, LGBTQ perspectives, and also members with experience in Pacific Health. Really important point I want to drive is that we're not the Ministry of Health. We are independent. While we cover, I guess, sort of policy and regulation, we don't have any sway over resourcing. So that's very much outside of ACART's ambit. What is within our ambit, though? So probably the primary function of ACART, which is of most relevance tonight, is issuing guidelines on assisted reproductive procedures to ECART, which is the Ethical Committee on Assisted Reproductive Technology, and to keep those under review. So ECART are a committee that's responsible for hearing applications on issues which are considered to be fairly ethically complex. We also provide advice to the Ministry of Health, and we monitor outcomes of assisted reproductive procedures in New Zealand. So we publish an annual report on our website on that, which is a fairly interesting read, to be honest. It covers the number of procedures performed every year, how many resulted in pregnancies, how many resulted in live births. So it helps us sort of, I guess, identify trends as things progress. So this is, I guess, just a real quick 101 on how assisted reproductive procedures in New Zealand are regulated, and I feel it's probably quite important to understand this if we are to talk about human reproductive research. So it's probably easiest to think of the regulatory regime as a traffic light. So on the one end, you have what are called established procedures. So these are set out in the HART order, which is a piece of legislation, and these can be performed by a fertility clinic without any ethical approval. So these include procedures such as in vitro fertilization, pre-implantation genetic diagnosis, or the freezing of sperm, eggs, and embryos. They're considered to be fairly ethically straightforward, so a formal ethical application process isn't needed. Then on the other end of the scale, you've got prohibited actions. So these are set out on the HART Act, and these are the things that you just absolutely can't do in New Zealand under any circumstances. So these include things such as implanting a cloned embryo, implanting a hybrid embryo, which would be an embryo which is made up of, I guess, human and animal genetic material, or implanting a genetically modified embryo into a person. And then in the middle, you've got the regulated procedures, which the HART Act defines as assisted reproductive procedures. So these can only be performed in New Zealand with approval from the Ethics Committee on Assisted Reproductive Technology. Probably the most common instances would be surrogacy, posthumous reproduction, and human reproductive research. And that probably makes up the lion's share of the work that ACART does. So issuing guidelines to ACART. ACART can only make decisions. They can only make decisions on applications to them if they've got ACART guidelines. It's therefore really important that ACART remains on top of things. In lieu of guidelines, ACART can issue advice to ACART on specific matters, but by and large, it's better that we actually have guidance for ACART good to go. Our work program is approved by the Minister of Health, so there is a degree of politics, I guess, involved with what we can and can't do. And I guess most crucially, we can only issue guidelines after we've consulted with the public. So consultation is a really, really important part of our job. And as I mentioned before, submissions to ACART have a massive bearing on actually the way that we often develop our guidelines. We publish the guidelines on our website. We also have to issue copies to the Minister, the Director General of Health, ACART, and providers. And I guess just to give you an example of what I mean when I'm talking about guidelines, these are the current guidelines that we have on our website. By and large, the one which is used the most is that top one, which relates to family gamete donation, embryo donation, the use of donated eggs with donated sperm, and clinical assisted surrogacy. You might have heard there's quite a lot of regulatory reform around surrogacy at the moment, so that's something we're keeping a very close eye on. The current guidelines are called the Guidelines on research on gametes and non-viable embryos, which gives you an idea of, I guess, the narrow scope of them. So we've got those under review at the moment. The third one down, Guidelines on the use, storage, and disposal of sperm from a deceased man. I'm hoping in the next month or two we'll be publishing updated guidelines on those, which cover a much broader spectrum of posthumous reproduction. I think the current set were published a really long time ago when the technology didn't exist for posthumous use involving a woman. So this is really just to bring the guidelines up to date and close a few inconsistencies in understandings around that. The guidelines on pre-implantation genetic diagnosis of human leukocyte antigen tissue typing, very rarely used. I think that's often referred to as savior siblings, where you're actually deliberately selecting an embryo with a certain tissue type to help another sibling with a genetic disease. And then finally, guidelines on extending the storage period of gametes and embryos. So this is a consultation we've just actually concluded. When ACART went into this, we were thinking it would be a fairly straightforward affair. We were just changing a wee bit of language in our guidelines to bring them into line with a few policy developments. A couple of submissions we got actually raised some really substantial issues that we hadn't covered and highlight a whole range of problems with the actual legislative framework around extending storage. So that's kicked us off onto what might be quite a big project looking at changing the rules around that. So just really to highlight how important submissions are and how much of an impact they can have on us. So just really quickly, the current state of human reproductive research in New Zealand. Our guidelines were published in 2005, so nearly 20 years ago. They were based on some Australian guidelines, which were published in 2004. The Australian guidelines have been updated multiple times since then, and the last update was as recent as 2017. Our New Zealand guidelines haven't been touched at all. Pretty much for the last 20 years, they stayed the same, and we haven't been able to look at them for various reasons. And like I said before, really exciting that we now are able to do that. So I think it's fair to say that a review of the guidelines are well overdue. And there's a tremendous opportunity at the moment for us to put in place something which is much more usable. And usability, I think, is probably the real issue with the current guidelines. It only permits research on gametes and non-viable embryos. And I believe Sarah's going to talk about what we mean by that in a few minutes. So by restricting research onto non-viable embryos, you do avoid addressing some of the ethical questions associated with research on viable embryos. Most notably, when does personhood begin? Does it begin upon conception, or does it begin some point further down the line? It does, however, also mean that human reproductive research in New Zealand is severely limited. There's not a huge amount of useful research you can do on non-viable embryos. And as a result, ACART sees very, very few applications to conduct research in New Zealand, which signals to us that it's not a particularly usable set of guidelines in its current state. It also raises a few other issues, particularly around the choices that people have when they have embryos or gametes in storage. Right now, if you have embryos in storage and you no longer need them for your fertility treatment, your choices are either to donate them or to destroy them. You don't have the option to donate them to potentially beneficial research. So there is the potential for extra choice there. So last slide from me, how can you help shape the future of human reproductive research? As I've said, we're reviewing the guidelines right now. One of the big things we're looking into is investigating whether research on viable embryos should be permitted. So we're going about this in two parts, a two-part consultation. Our first part, which is trying to find out what people's views are on human reproductive research, is out right now. We have it on our website, ACART's website. I think it's also up on Fertility New Zealand's website. We're accepting submissions until 31st of March, 2023. I apologize in advance. It's a pretty hefty document. It's about 80 pages. There was a lot of ground to cover. We have tried to put it together, though, that you can engage with it as much or as little as you want. You can either go through and answer every single question, or you can just put your thoughts on a page and give it to us. We would gratefully receive any approach. So, yeah, as I said, you can submit to us as little or as much as you want. All of it is extremely useful. And you can respond to us either in writing or verbally. So I think that's probably enough from me. I'll now hand over to Sarah to talk about embryos and where they come from.
Thank you, Callum. And you'll just notice me saying next slide to Callum because he's the one who's got control of all the slides and the rest of us don't. So we just wanted to briefly, make sure that people looking at this are aware of what embryos are and where they come from, and I'm sure many of you will be. So embryos are fertilized eggs. Quite often people talk about, when they say egg, they often don't just mean the human egg from an ovary. They sometimes talk about embryos as eggs, and sometimes when people say that they've had one baby and they've got some more eggs frozen, they really mean they're embryos. So sometimes there can be a little bit of confusion, but a fertilized egg means it's the result of an egg and sperm combining. So it's got both of those two, parts. And this picture just shows this is a human egg. The human egg is 1/10 of a millimetre. It's actually quite a large cell. And this is ICSI, where a single sperm is being injected into the egg. And you can see the sperm there, and there's another few sperm in the injection pipette, the injection needle there. That's called a holding pipette, which is holding the egg in place so that the scientist, the embryologist, can do that. And then here we've just got a little picture showing stages of embryo development. So this is the next day, usually 18 hours after fertilization, when they do the fertilization check. And you can see the two pronuclei here. One will be from the egg and one from the sperm. I can't tell you which is which, but the one is from each. The next day, what we call day 2, 2 days after egg collection, an embryo that's developing normally will have 2 cells. That's 1 day after 2 cells, 2 days after 4 cells. You can see 4 cells, and by 3 days after, usually 6 to 8 cells. And it's 3-dimensional. That's obviously a 2D picture. 4 days after egg collection, the embryo forms what's called a morula, and that's a rapidly dividing ball of cells. It's not a good time to look at the embryo. You can't count the cells and say a lot. And then hopefully some of the embryos will keep developing and become a blastocyst after the 5th or 6th day. And that's a ball of more like 60 to 100 cells with an outer layer of cells called the trophectoderm cells, and then a more obvious bit here that we call the inner cell mass. And those cells, if that embryo develops into a fetus and a pregnancy, that will be those cells will be the ones that actually form the fetus, the inner cell mass. We'll have the next slide, please. So the most likely and obvious source of embryos for research would be embryos that are remaining at the end of a person or couple's fertility treatment. So embryos that are no longer required because that person or couple have decided that their family is now complete. Occasionally, it might be because the relationship's broken up and those embryos are no longer going to be used for that reason, or sometimes people discontinue treatment for other reasons as well. But most commonly, it would be that their family is complete. Currently, options for remaining frozen embryos, as Callum has said, is that people go ahead and use them, meaning that they have them transferred and hope or try for further pregnancy, that they just choose to dispose of them, or that they can donate them to another person or couple. But that's an option that's only chosen by a fairly low number of people. It is a bit like an open adoption. People have to meet. It can't be anonymous. It's obviously very important for any resulting child to understand where they came from and have the opportunity to know about their genetic parents. And also, often people donating have already got children themselves from treatment. So any embryos that they donate would result in full genetic siblings in another family. So in this decision of what to do with remaining embryos, we're very aware that that can be a very difficult decision for some people, and we've been aware for many years that many people would probably like the option of donating the embryos to research, that they might feel that they were being a lot more useful, and that might be preferable to disposing of them. Next slide. So how long can embryos be stored for? Well, basically biologically indefinitely. So there's no evidence that embryo quality, or no particularly good evidence that embryo quality deteriorates with time. However, obviously you can have ethical issues with very long storage times. You know, there have been a couple of cases in the news more recently of babies born in the United States after embryos being stored for 25 or so years. And obviously that brings up some ethical issues about how old the genetic parents are, whether the children might have a chance to meet them, that kind of thing. Legally in New Zealand, anyone can store sperm, eggs or embryos for 10 years, and then you have to actually ask for permission to store for longer than that. And that's an application that needs to go to ACART, the Ethics Committee for Assisted Reproductive Technology that Callum's already mentioned, and it's really important that has to go in before the 10-year expiry date, as the law unfortunately currently is really black and white, that if you haven't had permission to extend, we have no choice but to dispose of the embryos. But you know, they can with permission be stored for longer than 10 years. Next slide. So viable versus non-viable embryos. So currently only non-viable embryos can be donated to research. So in practice, this is really only embryos that in our laboratory are considered not suitable to use to transfer into somebody's uterus to try for pregnancy or to freeze. So these are embryos that have stopped developing, that have got very, very few cells, or the cells are just all fragmented and abnormal looking. So they're embryos that we know have no chance of pregnancy. Embryos that are good enough to freeze might result in a pregnancy when they're thawed and transferred into somebody's uterus, so they're considered viable. However, we know that not all of them will actually result in pregnancy. So, you know, when an embryo is transferred, we might have a frozen embryo, we may have a 45 to 50% chance of pregnancy, and some of those pregnancies might miscarry. So we know that around half of those embryos are not going to result in a pregnancy, but there isn't a test that we can run on them that tells us whether they will or won't. So any embryos that are considered good enough to use are considered viable. And in practice, there's really not a lot that our laboratory staff could do in terms of research with non-viable embryos. One of the things would perhaps be, if they do have a reasonable number of cells, being able to practice biopsying, removing some cells off them, which can then get them some practice for doing that on better viable embryos when cells need to be removed for genetic testing. But there isn't really too much else that can be done. Next slide. So one of the other things is that, you know, in many countries, embryologists, scientific staff in the laboratories can train and practice various techniques using embryos that are no longer required for treatment. But here, as these embryos are considered viable, it also means that they can't be used for training purposes. And embryologists have very specific skills. It takes a lot of time and practice to learn these skills. And that's, as I said, that's something that in a number of countries, people could, donating to research could also include, or separately, it might be a separate category that people could donate remaining embryos to the clinic for training purposes. This obviously can speed up the training of embryologists and result in better skills for things like biopsying and removing cells from embryos. Next slide. And I think that's handing over to you, Karen.
Karen.
Thank you.
So, as Callum said, we're doing sort of part one of this consultation. And if you do have a look at the consultation document, that it is rather long, but you can have a quick flick through and read through. We've tried to provide some examples of the types of research that people might possibly want to do or be able to do, or research that is being done overseas that we can't do here in New Zealand. And so we want to know what you think about these, which ones of these, which examples you think should be allowed or shouldn't be allowed. So we've divided this up into different sort of research categories. So we have what we're calling clinical research. So we'd have standard clinical research, which would involve using gametes and embryos during a person's clinical treatment in an IVF or ART clinic, with the intention of enabling the parents to actually have a child from the embryo. But there may be some minor changes to the treatment protocol. And because this would involve collecting information about that embryo and the offspring later on, this is considered human embryo research, and so would not currently be allowed because it's using viable embryos. So, for example, you might want to compare some new commercial embryo media, compare it to the current media that the facility is using, and report on that data and do an actual research study. Or you might just want to analyse what's in the spent media, or the media that's remaining after the embryo has been transferred to the woman's uterus. So that's not specifically using the embryo, but it's looking at the media from the embryo and collecting data about the pregnancy and offspring. So it would still be considered research, even though it's not physically using the embryo. So that would not be permitted under the current guidelines. And another example of this would be what's called the day of transfer study. So this would be comparing embryos that were transferred on, say, day 3 of development compared to day 5 to see which ones were more successful at developing into a pregnancy. And that's something that clinics might do normally, but they wouldn't be able to report on that data or that study because it's considered research on a viable human embryo. So there may be some other more innovative clinical research that could be done. And these would be things that are not yet standard protocols in a clinic, but would be done with the goal of introducing new techniques or new protocols to the clinical practice to try and improve the success of the pregnancies. So one example is using a hormone called human chorionic gonadotrophin, which can be infused into the uterus before the embryo is transplanted or transferred to try and improve the implantation, or adding a new growth factor or additive to the culture media that we believe would improve the development of the embryo. And this sort of research would have to have evidence that it was safe. It would have to have been developed using probably animal models first before it could be introduced to a clinic. And then everything else would be classified under what we call non-clinical research. And this would involve research on embryos or gametes that would not ever be transferred into a uterus to develop into a fetus or a baby. Next slide, please. So some sort of examples of some potential non-clinical research. So remember, this is where there would be no transfer of the embryo to a uterus. Would include research with donated embryos to perhaps test new media additives or culture methods. So we could actually see whether those embryos developed better or more survived better. It could include research that actually creates embryos. So for example, if you wanted to improve methods for maturing oocytes in vitro or in the lab, to know whether those oocytes or eggs were actually improved or better, you'd need to fertilise them and see if they still developed into an embryo. Or you may want to create embryos from donated gametes, specifically for research. And there's sort of a subtle difference between those, but we're interested to hear whether you think that creating an embryo specifically for research would be acceptable in New Zealand. Another area of research is using embryonic stem cells. So because we don't have guidelines for using human embryos, viable human embryos, we cannot currently develop stem cells in New Zealand for medical treatments or any sort of research. I think I'll talk a little bit about this later. We may include things like cloned embryos, and that may sound a little bit alarming, but there are some specific examples for medical treatments or understanding rare genetic disorders that may benefit from being able to produce a cloned embryo from a person with that very rare genetic disorder. And then there's things like hybrids, so where you might combine and add some human cells into an animal embryo to develop human organs for transplantation. This is getting a little bit more extreme, but we still like to hear your views on this thing if you're interested in reading the questions in this area.
Yeah, I was just going to jump in really quickly and just reiterate that these are not proposals for what
No.
definitely will happen, but it's more like, what are your views on this? Yeah. just to clarify that.
So we're just trying to cover off everything that might possibly could potentially be done, and really hear what do New Zealanders think about. Where are the limits? Where do we stop? And I'll talk about blastoids a bit later. Another thing is genetically edited embryos, and as Sarah mentioned, the use of gametes in embryos for training. So next slide. So the prohibited activities under the Heart Act currently include, but are not limited to, transferring, i.e. implanting into a uterus, cloned embryos, hybrid embryos, and animal embryos or gametes into a human. And also the culture or growth of human embryos in the laboratory beyond 14 days after fertilization. So ACART is not proposing to amend these prohibited activities in the schedule of the Heart Act, but we're still interested in hearing if people believe that these prohibited activities should actually be permitted or not. So of course there's some very important ethical considerations that we have to bear in mind, and these include things like the status of the embryo, and people have a wide range of views on this. And these may range from that embryos are entitled to full human rights and protections right from the time of conception, to some people believing that the embryo is just a collection of cells that can't survive on its own and is not entitled to any sort of legal rights until perhaps after birth, and everything in between. I think most of us believe that embryos should be treated with respect, but there's various reasons for this belief. You might think the embryos are a scarce or valuable resource, or you may believe because they're potential people or a human life, then they deserve respect. As with all human research, informed consent is absolutely critical. So if it was a clinical research project that patients were donating embryos to, the patients will be fully informed and have the option to consent or not to participate in the research during their treatment. And for non-clinical research, the donors would consent to donating the embryos or gametes to the research. And that could either be for a specific research project that they know all about, or to what we call like a tissue bank or embryo bank that could be used for future unspecified types of research. But of course, embryos cannot consent, so it would be up to the couples or the people whose embryos were being stored to consent to the donation. And the researchers would have to apply to the ethics committee for approval to do the research. And this application, as with any type of human tissue or medical type research, would involve providing evidence that the research will add to our knowledge, will be of value and is safe. It would include details about the methods, what information and the consenting process would be for the people donating their gametes or embryos, and also how the results would be reported, who would own the data, and how the patient information would be kept secure. Next slide. So what would the benefits of research be? Of course, the main one would be to improve our assisted reproductive technology methods. So as you're probably well aware, only 22% of assisted reproduction cycles will result in a live birth. So by doing research on embryos, we may find ways to actually improve these statistics significantly, hopefully. We would also be able to better understand embryo development. You'll probably be surprised at how little we really know about how an embryo develops. How do the cells know where to move in the embryo? How do they know how to turn into the different organs and parts of the developing fetus? But we'd also be able to gain new knowledge that might either prevent or reduce infertility and miscarriage, improve embryo development, and potentially improve the health of the offspring later on. We now know that what happens in utero or even prior to fertilization can affect the long-term health of the babies born. We could discover new ways to avoid or treat inheritable diseases, and to identify which medicines and doses are safe to use during pregnancy. So you'll see that most medicines say do not use during pregnancy, but people have conditions such as epilepsy or things that need to be treated, but we don't really know what's safe for an embryo. Okay, next slide. So just a little bit more about the examples. I think we've already mentioned that we might want to use a new type of additive to improve the media that the embryos are grown in. We may have a new protocol for selecting the best sperm or the most viable sperm, but to know whether that protocol is which, we'd want to fertilize eggs and make embryos to be able to tell if those sperm were actually still viable and good. Embryonic stem cells. So as I said, we can currently only use ones that we've bought from overseas, so from people that have donated embryos overseas. And these cells can be reprogrammed to become any type of cell or tissue. So they could potentially be grown from patients' own embryos to grow cells that could be transferred back into that patient to treat a disease, and from embryos with rare genetic disorders to study that disease. And also for cancer research, because a lot of cancers and tumours actually revert to become more like embryonic stem cells that can grow and divide and survive well in the body. I'll just go through this quickly because I can see time's ticking by. So blastoids, the Heart Act defines an embryo as a zygote or a cell or a group of cells that have the capacity to develop into an individual, but does not include stem cells derived from an embryo. Now, blastoids are what we call artificial embryos that can be made either from embryonic stem cells or even other cells from the body, such as skin cells that have been reprogrammed to develop into an embryo. And these can be used to study embryo development and test drugs, etc. But at this stage, these blastoids or artificial embryos don't fully replicate a human embryo. So they have no way of developing. They'd never be able to develop into a fetus or a baby at this stage in research. So should these be considered embryos under the Heart Act, and should they still be limited by that 14-day rule? So whether we should be able to develop these blastoids beyond 14 days in the lab or not is a little bit of not clear under the current Heart Act. So we'd be interested to hear in your views on that. Okay.
I think it's back to me. Thanks, Karen.
Thanks.
So I think I've mentioned this several times, so I won't go into too much, but we do have a consultation out right now, and the responses to that will be used to inform updated guidelines. I think, as Karen said before, we're really interested to hear what people's views are on the different sort of range of research techniques. What do you consider to be acceptable? What's unacceptable? What are the big ethical issues? What are the safeguards we need? Really just any thoughts on that. So any views are really warmly accepted. And then we'll run a second consultation probably in 2024, early 2024, with proposed guidelines based on the responses we get. So the consultation document has been popped into the chat. You can also contact us at acart@moh.govt.nz. So yeah, I hope to hear from you. And I think that's probably enough from us. And now we're open to questions if there are any. So we do have a question, which is, can I choose what researcher to donate to, or does it go to a general research pool? And Karen, you're probably best placed to answer that. But I think the answer is it would be up to the individual, right? You would be able to choose.
Yeah, that's a really good question. And so there may be some researchers that are doing a particular research project, and they might actively recruit people from clinics to try and ask them to donate the embryos to a specific project. So then you would be informed about what the research was going to involve, why it was being done, what was going to happen to your embryos. But you may also have the option to develop to what we call a tissue bank or embryo bank that would store your embryos. Researchers could apply to ACART for permission to use those embryos, and some institution would be responsible for managing that bank and providing the embryos to the researchers.
So I think
it would be your choice of how and who you donated your embryos to.
So I think informed consent's a really important part of this process, so that the donors would have pretty much full control over who, what, when, how, as much as they want to stipulate or as little as they want to stipulate. And also making sure that they have the information needed to actually make that decision.
Yeah. So it'd just be very similar to what happens now. For example, patients with cancer having surgery, in some hospitals, they are given the option to donate their tumour tissue when it's removed to a tissue bank, and they'll consent to it being used for any research that has to apply to that tissue bank for it. Or they may be recruited into an active research program, and they'd be fully informed about exactly what their tissue was being used for, or what their patient information was going to be used for, and how it would be managed.
So the next question is, how detailed does my submission need to be? Which is also a very good question. And again, probably Karen, over to you.
Do you mean your submission to ACART about the consultation, or?
Oh, yeah. Actually, sorry, I thought it meant the submission to a researcher. No, the submission to ACART. It can be as detailed or as high level as you like. So I think it's totally up to the submitter. As I said before, any submissions are really, really useful. There's about 20 questions that we prompt in the consultation document, which cover a range of different types of research and questions related to that. But we also, I guess, just leave a blank text space for people to put any information that they would like to share. So
you could go through you could just go through the questions and say the first question is a yes/no question. You could just do the easy yes/no ones and not put any comments in, or you can give us a whole lot of your thoughts as well. We will be reading everything.
Yeah, the short answer is as detailed or as high level as you like. All of it is really, really useful. The next question is, what is happening overseas in Australia?
Yes, in Australia, they've been able to do research with human embryos for many years. They have some kind of interesting regulations, which I just found out recently, that, for example, if any tissue that is discarded from a fertility treatment, such as perhaps eggs that weren't looking good enough to fertilize, or maybe the cells from those eggs around them can be used in research without the person even knowing or consenting to it. So I would be quite horrified if we brought that into New Zealand, but maybe people wouldn't mind. But that means that they can actually do a lot more research than we certainly can do here. Yeah, but otherwise they undergo similar kind of ethics applications have to be made for everything, and all the information provided about what data will be used and how it will be stored and where it will be presented, that sort of thing. I think the blastoid question over there, they are able to do research on artificial embryos, I believe, without any limits to how long they can be grown for. And yeah.
Do you know off the top of your head, I'm just trying to remember what the UK situation is?
I'm not totally familiar with it at the moment, but yes, they
can definitely do research on embryos. Not sure exactly what the wide limits are around that, but they can do research on viable embryos.
Yeah.
So typically the UK and Australia seem to have really similar, I guess, regulatory regimes as us in this space, and certainly in research, I think we're quite far behind. As I mentioned earlier, our guidelines were based on 2004 guidelines, and they've kept those up to date, kept updated, and kept moving with technological advances. And in New Zealand, we just so far haven't moved. So I think there's probably a ground for us to catch up.
But there's also the kind of ethical question around that. So we do ART treatments using information from research that's done overseas on human embryos in other countries. So is it ethical for us to do that without contributing to that knowledge base? And,
yeah, I guess you could argue as well that if we're using techniques which are resulting from research overseas, that we've kind of already accepted the ethical permissibility of that research.
Yeah.
So the next question is, with the informed consent, does that mean I could donate to training but not to research, or vice versa? And again, I think the answer is absolutely yes. So the donor gets full control over how their embryos or gametes would be used.
Yeah, I mean, that will depend on how we write the guidelines, but I think that we'll definitely be trying to make that an option, knowing that people will have different views about what sort of use they would like to be, allowed.
Oh, this is a good question. What happens when embryos are destroyed at the moment? Is there info on how many? Sarah, I think that's probably...
I can answer that. So if embryos are, we probably don't quite like the word destroyed, but disposed of, I guess there's no word that is perfect. They are, everyone in a fertility clinic, the embryologists absolutely treat all embryos with respect, but they are, they're usually frozen in special little plastic or glass straws in liquid nitrogen. So those straws containing the embryos for that person or people would be taken out and allowed to, just to thaw at room temperature and just to succumb if they're just left at room temperature and they're not put in embryo culture media and the things that they need. They will, they will no longer be viable. People have the option, are always offered, do they want to come and collect them? Some people might want to come and collect the embryos, and if they did, they would receive a little tube with a little bit of fluid in the embryos. The embryos are microscopic. They wouldn't actually be able to see them, but they could if that brings them some comfort or peace to take those home and maybe bury them or do something like that. They're absolutely welcome to do that. Otherwise, they would be, once they'd been thawed, if somebody didn't want to collect them, they would be disposed of along with other medical waste. So in the containers you see in hospitals where, needles and everything else goes, there's medical waste containers, and that is usually incinerated. There's companies that deal with that and they come and take it and incinerate it. I can't give you a figure, but there would be hundreds of embryos disposed of in New Zealand every year because people have completed treatment and no longer want to store them. When the 10-year law came in 2014, so 10 years after the Heart Act came in 2004, that was the first point at which we had embryos coming to 10 years or more. And if people don't extend the storage, then we have to dispose of those embryos. So we have a number of those cases each year. So, I haven't got any exact figures, but, there is a considerable number.
So just, I guess, a sort of personal experience of this. My partner and I, we've got embryos in storage. So we've completed our family. So we have, I think, 4 viable embryos and 2 embryos which would be considered non-viable because they've got cystic fibrosis in storage. And so our options with the viable embryos would be either to donate them or, I guess, destroy them. Even if we would love to donate them to beneficial research, it's not an option at the moment. It's really interesting. I studied this area in my postgraduate studies before I actually had any inkling that one day I'd be a consumer of these services. And I must say, I feel very different about the embryos that I have, now that I'm in the situation than I did, I guess, when I was looking at it from a more academic point of view. The decisions are a lot harder when you're in that decision, in that position than I expected. So, yeah, it can be quite a tough one. And destroying, I hate the word, but destroying embryos that you have in storage, it's a really difficult decision. We do see people applying to ACART for an extension to the storage, of their embryos, not because they intend to use it, but because they're still sort of, I guess, coming to peace with, destroying their embryos. So, yeah, it's an interesting thing with human reproductive research because it could potentially provide another avenue where, these really precious resources could actually be put to, a higher purpose, I guess.
And yeah, we see in the clinic all the time people who perhaps at the beginning of treatment might not be at all concerned about having excess embryos above what they need, but if they've had children and completed their family, they then, I think, do quite often look at their embryos differently and find it, do find that decision difficult to varying degrees. So, and I'm aware that we've got some people continuing to store embryos because they're hoping that they will be able to donate them to research. So, and hopefully that's what may come out of this, but we'll just have to see what people think. But that's why it's really important for people listening, people who've got stored frozen embryos or been in this kind of position, consumers of fertility treatment are the people where, are some of the most important people in this. So their views are really, really important.
Can they currently do research on your non-viable CF embryos, Callum? That would be really valuable. Well, it's actually a really good question.
They wouldn't actually be non-viable because
I agree. I think they wouldn't. Yeah, so
So I guess that's one of the real issues that we've bumped into is the definition in the current guidelines is really useless. I mean, the current definition of non-viable just so I don't think it even encapsulates those, I guess, cystic fibrosis embryos, which you wouldn't be allowed to donate, you wouldn't be allowed to implant. And yeah, I guess if they're not defined as non-viable, you can't donate to research. So, and I completely agree. That would be really valuable. I mean, think if you could have research which, could treat cystic fibrosis or identify it earlier on or help with genetic testing, it would be amazing. It also raises sort of an ethical question. Could we deliberately create cystic fibrosis carrying embryos for research? Which, that's a really tricky ethical question as well, right? You're deliberately creating embryos which will never be, never have a chance of being born, I guess. So that's something we do explore in the paper as well.
So that, one of the issues with this non-viable business is that it's a very subjective thing. The clinician, the embryologists look at the embryo down a microscope and think, well, it seems to have some not very good looking cells, so we don't think it's viable. But actually, if it was implanted, some of them do still survive and grow. They have enough good cells to keep surviving. So we really cannot tell which is unless it's completely sick and dead, then it's non-viable and not growing. But there's a sort of a very grey area.
So the issue with the definition, right, in my case, is those cystic fibrosis embryos could still be implanted, like theoretically, right, and they still could grow, so therefore they don't meet the criteria of non-viable. I think that's the problem, even though you just wouldn't be allowed to implant them. Yeah. How long could it take for this to change? I'm presuming that question relates to changing the sort of regulatory landscape. So frustratingly, it does take a wee bit of time to to go through the whole process of updating guidelines, particularly as something as substantial as this. My goal is by the end of 2024 to have the new guidelines published. So, I mean, it's nearly 2 years away, but I'm thinking about all the steps that we need to go through. I'm like, it's at a fair clip. But I think, end of 2024 would be realistic. So this consultation we've been running since, I think October through to the end of March. We deliberately made it quite a long consultation. We were also very deliberate to try and get this done before election season kicks off, because anything related to government ministries just grinds to a halt. So we really wanted to get the consultation out and get people's views so that we could spend the next sort of 6 months considering those views and what kind of guidelines to put together. I'd really love the next consultation paper to be out early 2024. A couple of months on that, and then that should give us 6 months to get advice to the minister and guidelines published. It does become a bit slower if we need to make changes to the legislation. That's a massive process in itself. I think for the most part, though, we could publish guidelines and that would do, I think, 90% of the job. It just depends what else comes out. It also coincides at the end of 2024 is when I'm finished up on ACART. So I would have done my 6-year term. So I'd really like this done by then. I think we're nearly done on time. Thank you very much for those questions. Those are really good. We do really appreciate people engaging with us on this. And as I said, your submissions are really, really valuable to us. They can have a substantial impact on our work and the direction we take. So like I said, big thank you to everyone who's tuned in, and thank you in advance to everyone who takes the time to submit to us.
Thank you so much to Callum, Karen and Sarah for that presentation. We had a number of questions coming through from Facebook Live as well. So it's just been really great to see the range of things that people are interested in response to this. So that's really cool. I just want to thank you so much for your time this evening and for bringing such a valuable opportunity to our community. I like you said, Callum, you mentioned it, but I definitely know that there are other people out there who are holding on to and storing embryos for this potential change in legislation, which is really exciting. So really appreciate that. And this webinar will be recorded and available on the Fertility New Zealand website, and we'll post it onto our social media as well. So if you were only able to see part of it, you'll be able to catch up on the rest of it, or come back and revisit some areas that you may want to watch again. But thank you again so much, and I hope that everybody has a lovely evening.
Thank you.
Bye, everyone.
Bye.